Waves are all around us, just like in this pool of water. The sounds that we hear and the light that we see travel in waves. Understanding waves is very important as it allows us to describe electrons in an atom and to understand different forms of electromagnetic radiation. In this video, we are going to look at some of the basic properties of waves. There are two main types of waves. Progressive waves move matter or energy from one place to another. For example, if you hold a rope at one end and sharply move your arm up and down, it will start a progressive wave. Ripples in water are another example of a progressive wave. The second type of wave is a standing wave. This wave does not move objects or energy. For example, if you fixed one end of a rope to a wall and then moved the other end up and down, it would cause a standing wave. The waves on a guitar string are another example of a standing wave. All waves, whether they are progressive or standing waves, have a number of common properties. Wave properties are relative to the baseline, the position of the wave if it went flat. You'll notice that half of the wave is above the baseline and half is below. The maximum points of the wave above the baseline are called peaks, and the minimum points are called troughs. The height of the wave from the baseline is called the amplitude. For a standing wave, the amplitude is the maximum height that the wave reaches. There are some points on the wave where the wave is at the baseline. These points are called the nodes. For a standing wave, these nodes remain in the same place. So the nodes are points on the wave that are always at the baseline. They never move. Finally, a wavelength is defined as the distance between two successive crests of the wave. It can also be thought of as the distance from one node through a peak and a trough to the next node. Let's consider these two waves. They have the same amplitude, but the wave on the left has a longer wavelength than the wave on the right. Another important property of a wave is its frequency. That is, how often it goes through a node or a peak or a trough. The wave on the right has a higher frequency than the wave on the left because it is going through more nodes. The effect of a higher frequency is that the wave will have more energy, so the wave on the right has a higher energy than the wave on the left. If the wave is a progressive wave, then it will move more matter or energy if it has a higher frequency. Up to this point, we've only been looking at waves in one dimension, but the same principles and the same properties of wavelengths and nodes and frequency applies when we think about waves in 2 or even 3 dimensions. One specific type of wave is electromagnetic radiation, which is a type of progressive wave. Electromagnetic radiation spans from the very short wavelength gamma rays on the right-hand side to the very long wavelength radio waves on the left-hand side. Remember that frequency is inversely related to wavelength, so gamma rays have the highest frequency and the highest energy, and radio waves have the lowest frequency and the lowest energy. A special subset of electromagnetic radiation, which only occupies a very small part of the spectrum, is the visible light. The color of visible light depends on the wavelength. Long wavelength light is red, while short wavelength light is blue or violet, and the other colors of the rainbow lie in between.